Hello and welcome back to Richard's Home Mechanics. The job we've got in order today is on a Honda CBF 125 on a 59 plate. The issues are the battery is not charging, so we've got an issue there from the alternator stroke stator, and also we have lost the front and back lights. I do believe that is connected also to the alternator, as these bikes do not have an on and off switch and they run permanently on. I do believe that is a safety issue. So let's crack on and let's start testing and see if we can find the reason why we cannot get this bike to start and the lights to run. Okay, let's crack on. Right, what we're going to do now, we're going to do a dead test, a continuity test using the old faithful meter. What we've got here, we've got the power lead comes out. Let's identify these wires. We've got a multiple plug with 2 pins and 2 wires there. The 2-pin plug here is the main coil, comes round here, wraps all the way round the stator and comes back up. That's what feeds the regulator rectifier, which runs everything, the ECU and the brains. These 2 wires here, we'll identify them, is a yellow and a white single wire and a blue and a yellow. They are for the pickup, which are also connected inside the stator cover here, and therefore the timing of the spark plug. So every time there's little marks on the flywheel, every time it touches that sensor, it sends a pulse to send spark plug to spark. Now obviously if you disconnect that, you ain't going to get a spark. So if you ever get a no spark, don't automatically go for spark plug. Always check these. If this has come loose, you won't get no spark, because the ECU will not know when to send a spark, so it'll just stop sending it. Right, very quick simple continuity test. Here we go, the old faithful meter. Send it to what are we on, Omega. There you go. I'm going to zero my leads. Not too fussed about taking off the resistance, and we've got a 0 on them anyway, so that's cool. And what we're going to do, we want a continuous coil circuit coming from the green wire or the white wire, comes into there, goes all the way around the windings, all the way round and back out on the white. So it doesn't matter what way you do it, green or white, white or green. And this is on the white plug on this particular Honda CBF 125, and we're looking for a continuity. That's all I want at the moment. Now here we go, let's just hold that in there. A little bit fiddly once you've got it, there we go. Right, we've got a continuity of 0.6, there you go. I'm happy with that, that coil's working. But we've still got an issue, that we've got no charging and no lights. Possibly still think there's something wrong in there. I'm aiming towards there. What we're going to do, we're going to move on to a live test. So we're literally going to start the bike up. I'm going to jump it with a jump pack, and we are going to go back on here on the white and the yellow. That is, don't forget, that's the voltage coming out. Just to make a note, that is AC voltage. So if you test these, you need to have your meter to AC, which is alternating current. And we're going to see if we get any volts coming out of here. If we've got no volts coming out of here, there's no way on earth that rectifier is going to work. And then if the rectifier's got no power, you've got no charge, you've got no lights, you've got nothing. So I think we should move on to testing this alternator and see if we can get any volts actually coming out of it. Okay, I've managed to start it. I've literally just put a power pack, a jumper pack across the terminals of the negative and the positive, and we've got it running. So the bike runs, but it's got no lights, front or back. Brake light works, but that runs independently off the battery. So basically, we need to know if there's voltage coming from this stator stroke alternator up to the rectifier regulator. Now the rectifier regulator, what that does, is AC that comes out of here. It goes into the regulator alternator, and the regulator alternator converts it to DC. Bikes, these run on 12 volt DC. So basically, if we get no power to the regulator rectifier, we're going to be starting investigating here. If we've got power coming out of here, then the issue is possibly up to the rectifier, so we're going to back trace the wires. Well, let's just test. So I'll be hoping to see, so we're going to set the meter. This is alternating current, which is AC. So let's have a look. AC is the little wiggly biggly bit there. Now, I would expect to be seeing between 15 and 20 volts. If we don't get any volts, we need to take this cover off on this Honda and see if we've got any burnt coils or something maybe amiss in there. So let's go. very, very careful. Insulated leads. Do not put your fingers anywhere near the tips. People will say I've got long tips. That's because I've been probing a bit deeper, but do not touch any of these tips. You keep your fingers here. Now I'm getting 3 volts. That ain't going to run a sausage. 3 volts on AC is not going to run a sausage. I'm just going to give it a rev. Look at that, look. Okay, so that looks like we take that off. I've got to take this cover off and investigate further. There's no point. Hang on. Now the reason that's stopped or stalled or stopped is basically there's no power in that battery. Now, this bike needs 12 volts or 13.8 volts to run. Obviously the battery's flat, it's not getting charged, and it's just died because there ain't no power to run the spark plug or run the no power to run the ECU, the control unit. So what we're going to do then is we are going to take this cover off and see what's going on behind there. I suspect this is the problem. If it's not, no, it's here. I think it's here, because if we've got no voltage coming out of here, it starts here. So if we've got no voltage, there's got to be something wrong here. So let's crack on and let's have a look and see if we can find it. Okay, let's get these covers off, shall we, and have a look what's going on. Just got to take this cover off to get this one, because this back cover covers the stator cover, stroke alternator. I call them alternators because I'm used to working on motors that have alternators, but on a bike they're called a stator. Does the same thing, it generates AC electricity. Right, get that one out of the way. Pull that out of the way, be very, very careful. Always noting where everything goes. Now I've already cracked these bolts off to save a bit of time. Here we go. Right, let's put these in order. So that goes from there, just in case of different lengths. Which they are. Right, okay, so they are different lengths. This is another thing to remember when you're taking casings off. They're all different size lengths, so lay them out in the order that they come off. And what I'm going to probably do is I'll stick them in a bit of cardboard, because it just saves time when you're reassembling. You put the bolt in that's too long, you put a bolt in that's too short, you're fiddling about, messing about. Just put it in a bit of cardboard and mark it. That's how it went on. Simple. Cut a hole in the cardboard with a screwdriver, punch a hole, job done. So, nearly there. So I'm keeping a note of these, the way these are coming off. I'll re-transfer that to cardboard. Normally I have the cardboard ready when I do it, but I thought they'd all be the same size, but obviously not, same length. All the same size, but different lengths. But I know the way they come off, I can remember, so I will transfer that to a bit of cardboard. See, this is a long one. Very long. Let's have a look. She's out. Nearly there. A couple more. Surprised how many bolts hold this on, actually. Jesus, there's a lot. Got one. Still keeping them in order. Mustn't forget. Crack that one. She's cracked. Dee 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 dee. Dee dee dee. There we go. Nearly there. Right. One more. Right, here we go. The way to get these off, if they don't come off, little rubber mallet, not metal but rubber, give them a little tap. Here we go, see that? Broke the seal. The rubber doesn't hurt it. Okay, as you can see, we've taken the cover off. I've already taken the stator out, but we'll have a look at that in a minute. But what I'm going to show you to do, this has obviously got the old gasket on. So what you need to do, you need to get this old gasket off. I bought a new one. And the easiest way I found of getting the gasket off is using a Stanley blade. But it can be a little bit dodgy holding the Stanley blade because you can slip. So what I bought, you can buy one of these off eBay for about £2, £2.50. And it's a little handle, very simple device. But Stanley blade, that's your normal Stanley blade. It goes in your Stanley knife. Just sits in there like that, slide it in, it's nice and safe, look, so you ain't going to cut yourself. Best one, all you do, so look how nice that is, take the gasket off, look, nice and easy, just keep scraping round, very, very simple. Just be careful not to dig deep, because you don't want to gorge this. Look how easy that is. That comes off. So simple. There you go. Touch it off like that. A little bit there. We'll carry on taking it off. So you need to, every time you take any sort of gasket off, whether it's car, motorbike, any sort of engine, especially if it holds oil, you need to replace. Don't use the old gasket. Replace it. Put a new one on. Now how simple and quick was that? What I will do now, just to get that nicely, make sure how lovely it is, nice and clean, is I'll get a little bit of 1500 wet and dry, and I'll give it a very slight clean. So let's put that to one side for a minute. Right, this is the stator. This is what powers your electricity on your bike. This creates AC. This basically sits in there like that, very simple, which we'll replace in a minute. That sits in there like that, and this goes on the bike like that, and it sits inside like a flywheel. Now as the engine is turning round, it causes an electromagnetic force, and with the windings, etc, etc, and the reaction, you end up with AC, which is alternating current, which comes out on this particular model, is the white and green wire. So this is what we suspect is faulty, why A, it's not charging up, and B, I've lost lights. Let's recap. Let's put this out of the way. Basically, this powers up AC to the regulator rectifier on the bike, and the rectifier regulator converts the AC produced from this stator to DC, which is direct current, and then that powers up, keeps your battery charged, it runs your lights, it runs the, I think this has got fuel injection on the bike, it runs the ignition, the timing, it does everything. So basically you start off with an AC and it's converted to DC. And this particular one, which is very unusual, normally the lights are run via the battery. But this one, the lights, because they're day running lights, and I think that's a new issue. I've been riding bikes for years, but it tends to be that the lights on this one, I can't even turn the lights off for safety, which I think is good, because when I used to ride bikes, I used to ride with lights on all the time. But I've also got failed lights, which is a dead cert that this coil is faulty. This stator is faulty. Now, if you look very carefully, I'm not sure you're going to see it, on this winding here, very, very black at the bottom. That's not a good sign. I mean, something's burnt there. I think this is faulty. I really am quite confident this is the issue. So what we're going to do is we're going to replace it, and here we have a new one here. So let's get on and refit it into the case, which we're going to do next, and then offer it up to the bike. And once we've got it up on the bike, we're going to connect it all up, and we're going to fire up the bike and see if she runs. And what we're looking at, we need to get a voltage across the battery terminals, which I will show you when we're testing, of at least 13 to 6 to 13.8 volts. That would keep everything running nicely, and we need the lights back. So let's crack on. Let's get this mounted in here and get it back on the bike, and then we can test and see if we've cured this issue on this Honda CB125 with no lights and no charging of the battery. Okay, let's get this stator back in. What I've done, this stator just sits in there. It's got 3 little grub Allen keys, yeah? Take a note, when you take yours out, whatever bike you're working on or whatever vehicle you've got, it's got a stator. On this particular model, this stator can go either way. That can fit in like that, or it can fit in like that. I took a note, and best way to do that is take pictures or a drawing. And I noticed when this stator fits in this cover here, the wires approach from underneath and went into the top like that. That's how I know this is the right way round. So we've got that in there. So then what you do now, you've got your main feed cable come up here, black one. And you've got a little rubber grommet. Tuck the rubber grommet in there. And what you have now, to keep this cable out the way and nice and safe, we have this little cover. And what that does, that just sits over there. It's a little plate, and that holds all that nice and neat. And that, again, is held in with a little grub screw. Let's just get that in there. Like so. Here we go. Now I need to hold that in place. I do this up, and what that does, that keeps the cable out of harm's way. So when that flywheel is spinning round, it doesn't catch the cable. So again, I'm not going to nip that right up tight, but you can see the gist in there. Probably better if I get a torch in there. That keeps that nice and neat, keeps that cable tucked under that. Okay, and then the next stage is you have what they call a pickup, which sends a signal to tell when to spark. And it's here. So we need to put this in again. Make sure you take a note of how it goes in, how it come out. Now I know this come out like that. So again, this just sits in there nicely like that. Like so. Again, I'm not nipping these up tight, because I'm just going to show you how it goes in. Like that. So basically that goes like that, and I believe that tucks up down there somewhere out the way. And that there is now ready to install onto the bike. So let's get this on the bike. Obviously we're going to put a new gasket on it. Let's get down on the bike now, get the new gasket on, get this zipped up, and let's fire her up. And then if she starts, let's check the voltage across the battery with the multimeter, and let's see if we've got lights. So let's crack on and get this on the bike, shall we? Okay, what I normally do when I'm doing a job like this, before we offer this back up with the new gasket onto the side of the engine, I like to have a final check, because once I've mounted it, I can't see what's going on in here. So what I've done, I've rechecked the 3 Allen keys, then 1, 2, 3. I've checked the pickup for the timing, for the spark plug timing. They're nipped up, and I've also made sure that the Allen key in there is nipped up. All cables are nice and neat, as you can see. All the cables are nice. The rubber grommet is there. So we're now ready to offer this up to the bike. So let's do exactly that. Let's get it on there and see if we can get this running. Okay. We've got the alternator stroke stator back in. Let's see if we've cured this problem. The issue was the battery wasn't charging up, so obviously the bike wouldn't start when the battery was flat enough to run, and I'd lost all the lights. So let's start it up, and then let's put a meter across them terminals, the positive and negative, and see if it works. Well, that's a good start. It started. So let's get the old meter out. When we tested it last time, it wasn't charging at all. It was only a negative voltage. So let's have a look. I want this to be sitting around 13, at least 13.4, 13.6. Let's have a look. That's even better. Look at that. We've got a voltage of, what's that, 14.7, 14.29 hovering. That is perfect. So we now know that when I start this bike up, it's going to recharge up. So that's an issue, we fixed that. So we've definitely fixed that. Now we need to see if we fix the lights as well. If we have, that's the result, and it'll be back on the road again. Okay, as you can see, we've got lights back. So this bike, which is my personal bike, which I use every day, come rain, sun or shine, it's back on the road. I'm happy with that. So, quick recap. Let's turn this engine off. The issues we had on this, very similar. Doesn't have to be a Honda. Any sort of motorbike or anything that's got a stator in it. I noticed straight away it wouldn't start. Battery was flat. Re-jumped it, it went flat again. So, as you've seen my video, or you're about to see my video because you fast forwarded, we followed through the fault finding. We quite quickly found it. It's not hard. We found that the continuity seemed to be fine, but when we took the stator out, we could see that the windings were burnt. So again, I've said in my videos, you may do a continuity, and I do a lot of my testing with continuity, but sometimes you still have to do a live test. Obviously very careful, and make sure if you do live tests you have a decent meter with decent isolated probes. We've discovered like the continuity seemed to be okay within spec, but there was no voltage coming out that stator. We've now replaced the stator, and we've got the lights, and we've got the charging back, so it's happy days. Thank you for watching my video. If you do like my videos, please subscribe and put a reminder, tink that bell. I've got more and more in the pipeline, and I'm getting more and more subscribers and more viewers, and absolutely love it. So if you do find this interesting, or drop me a message, you know, I like to have a chat about mechanics. Nice one. Thank you very much. Thank you for taking the time to watch my video, and we will see you in the next episode of Richard's Home Mechanics. You never know what's coming through that door. Bye for now.